Write an equation for a line parallel to f of x is equal to negative 5x minus 3 and passing through the point 2 comma negative 12. All right, so this sounds a little complicated, right? But now remember, so first thing is, if you don't like this notation, a function of x, you can always call this simply y. Doesn't matter, okay? So I'm going to rewrite that as y is equal to negative 5x minus 3. Now, doesn't this particular equation kind of follow the general form of y is equal to mx plus b? Sure it does. So what then do we know? Well, we know then the slope. The slope of this line here is going to be negative 5. We also know the y-intercept, right? It's going to be negative 3. So if we wanted to get a quick visual, let's just try to gain a little visual understanding here. How would I graph this line? Well, I would basically start probably with the y-intercept of negative 3. So that means I would go down about 3 points, 1, 2, 3, and I'd plot a little dot. Okay. Then what does it mean to have a slope of about negative 5? Well, that means that I would go out 1 unit on the x, because remember this is really like saying negative 5 over 1. And remember the slope is always the change in y over the change in x. So that means I went out 1 on the x, and then I got to go down 5 units on the y. Okay, so maybe that point is about around, let's say maybe it's around, I don't know, I'm making it, actually let me try to do this a little bit to scale. 1, 2, 3, 4, sure, 5. Okay, let me extend this on down. And let's say this is about 1, 2 or so. We'll go there. Okay, so here this is about where that line is. That point, excuse me. Now I'm going to draw in the line. So there it is roughly. Okay, this black line right here represents this equation. Okay? Now what we need to do is we have to write an equation for a new line, and a new line that is parallel to this black one. So what are some of our options? Well, it's basically any line that's essentially parallel to it, right? So maybe it's here, maybe it's here, maybe it's there, maybe it's here, maybe it's here, maybe it's here, right? It could be anywhere, it could be anywhere along that, okay? So now, where is it? Well, they gave us one other additional piece of information, right? They gave us, it has to pass through 2 comma negative 12. Now, since I'm not doing this totally to scale, might be a little off, but let's see. So now what I got to do, what I'm going to do is I'm going to plot the point 2 comma negative 12. So if this is 2, I have to go down all the way to negative 12. I don't know, maybe it's somewhere here. Okay, I'm making it up. I might be slightly off. I'm probably off, but let's just leave it alone. Remember, this isn't totally to scale. But now I know that this line here has to pass through, and this doesn't look totally parallel to me, so I'm going to just adjust that ever so slightly. What do you think about that, guys? Pretty good? All right. So this line here will represent the line that's parallel to the black line. Okay, and we know one of the points here, right? We know that this particular point is going to be 2 comma negative 12. Now my first question is, what is similar or basically the same amongst these two lines, amongst the black line and the red line? What's the same? Remember, they're parallel. So parallel lines have the same what? They have to have the same slope. So let's start with our general equation. Y is equal to mx plus b. We know it's a linear line, so that's why we're going to start with that equation. What is the slope then of the red line? Well, it's the same thing as the slope of the black line that we drew, which turned out to be negative 5. Okay, or negative 5 over 1, it does not matter what you write, because they're the same. So let's type in, or let's write in negative 5 there for m. Okay. Now, remember, what defines a linear line is two things, the slope and the y-intercept. So if I need to create an equation, what that really means is you got to give me this form, y equals mx plus b, with a known slope and a known y-intercept. We know the slope because it's parallel to the other line, so that's the same. But what we don't know is now this y-intercept. Okay, so what we got to do is we got to go hunting. We got to go find that y-intercept. And if we notice the y-intercept might be a little bit above it or a little bit below. Again, I don't know because this isn't totally the scale. But the important thing here is that we're definitely not going to figure it out graphically, especially if you're not using graph paper. Okay, we have to figure it out algebraically. So take a look at this equation. If I want to find b, that means I gotta know everything else. That means I have to know what y is and I have to know what x is. Remember that y and x in a linear equation represents any pair of coordinates, aka any point on the line. Any point, any single point. It's always going to work out. Any point. Now it turns out, scared me there for a second. If you didn't hear it, the door kind of closed on its own. There's ghosts in my house. Help me. So it turns out that we know one point. They told us that it has to pass through the point 2, negative 12. So remember, every coordinate, you know the x and you know the y. So guess what? What I'm going to do here is I'm going to take now my x value of 2 and plug it in here. And my y value of negative 12, and I'm going to plug it in here. And take a look at what happens. So there's going to be negative 12 equals then negative 5 times then the x value of 2 plus then b. And wait a minute. Is this equation really just with one unknown right now? Why do we love that? We love that because we can solve then for that unknown. Okay, that's a very useful technique in problem solving, especially in math. If you have to figure out what b is, and you know b is part of this equation, the only way to figure it out is if you know what y and x are. That's it. So that becomes essentially the new question for yourself. It's not what's b anymore. It's now what's y and what's x. Because if you keep focusing on how do I find b, you're not going to get anywhere. You got to change the question. You can't figure out what b is unless you know what y and x is. So that becomes the new question. What's y and x? How do I figure that out? What does it mean? What does y and x represent in this equation? Or it represents any single point along the line. Oh, okay. Do I know a point? Sure, they gave it to us. Oh, I just plug it in then? Yes. That's it. And now, once you do that, it becomes solvable. So watch. So negative 12 is going to be equal to negative 10 plus b. Solve that baby for b, so you're going to add 10 to both sides. We realize that negative 12 plus 10 is going to be a negative 2, and that's equal to b. So this is what b is. And it turns out that my line here approximated it roughly. Okay, close. Right? The negative 2 would have been right around here. Okay? So the line's off by a little bit, but I kind of figured it might be. So we're almost there. Remember, they want an equation. So just take the slope and the y-intercept and now plug it all in. So the new equation of that red line is going to be y is equal to negative 5x minus 2, because the y-intercept there is a negative 2. That's what we found. And this, ladies and gentlemen, is my equation of that red line. Okay? So let's take a look at the second example and let's see how fast it goes, okay? So it says write an equation for a line parallel to this thing and passing through this point. So remember, just rewrite this. Y is equal to 3x minus 1. I'm not going to graph it all out. There's no need. Okay? So because we're going to try to figure out how fast we can do this. So remember that this is the equation of the line that they gave us. Remember that this follows the form mx plus b. So I know that the slope here of this particular line is going to be 3, and I know that the y-intercept is going to be 1. I now need to create a new equation for a new line, and it's linear, so I know it's also going to follow the mx plus b. But I do know something about this line, this new line, in relation to the equation that they gave us, that the lines have to be parallel. As soon as you know that they're parallel, that means that the slope of whatever line that it's parallel to is the same as the slope of this. So what that means is now I'm going to take y is equal to 3x plus b. Same thing. In order for me to write the equation of the line, remember, at the start, what that means is that you got to know the slope and the y-intercept. Maybe it's y is equal to 3x plus 4. I'm making it up, right? But we got to know the slope and the y-intercept. So we do know the slope because they told us that it's parallel. The next thing is to figure out what that y-intercept is. And remember, they told us that the new equation, the line passes through this point. So they gave you a point on this new line. Anytime they give you a point on this new line, they're telling you what x and y are or is. I don't really know. Don't ask me about English help. So 9 is going to be equal to 3, then times 4. Look, I just simply plug it in. And now I got one equation with one unknown. 9 is going to be equal to 12 plus b, minus the 12 on both sides. And we realize now that is going to be negative 3 is equal to b. And lo and behold, I can now write my equation because I know the slope and I know the y-intercept. So it's going to be y is equal to 3x minus 3. Voila. Guys, thank you so very much for tuning in. I really do hope this video helped, and if it did, help us out by telling your friends. We'd love to help more people, and also hit that subscribe button and like button. Thank you.